Okay, we're going to go ahead and start talking about predicting the products of chemical reactions. And in order to predict the products of chemical reactions, you first have to be able to identify the reaction type that you're dealing with. And so the first type of reaction that we're going to deal with is a decomposition reaction. We can tell that this is a decomposition reaction because we have one reactant yielding products. And that one reactant is going to break down. So let's go ahead and label that decomposition. Okay, so once we have it labeled as decomposition reaction, we need to figure out what our products will be. And for many different decomposition reactions, it's not as simple as them breaking down into the individual elements. So from time to time, I'll have to tell you how many products that you're going to yield. In this case, it is a simple decomposition reaction that's going to break down to aluminum plus chlorine. And we have to remember that chlorine is diatomic, and when it is diatomic, that means it comes in pairs when alone. So we have chlorine by itself, so therefore it's Cl2. Now we have to go back and balance the equation. Let's do our atom count first. On the left side, we have 1 aluminum. On the right side, we have 1 aluminum. On the left side, we have 3 chlorines. And on the right side, we have 2 chlorines. So in order to balance this, I need to increase the chlorines on the right side, which will also mean that I have to increase the chlorines on the left side. So the only way I can make 2 and 3 equals by finding a common multiple. So we're going to multiply this by 3 to get 6, which means we're going to have to do the same thing, or multiply the left side by 2 to give us our 6. And that changes our aluminum to 2. And then we simply need to multiply the aluminum on the product side by 2, and we end up with a balanced chemical equation. The next type of reaction that we're going to look at is going to be a synthesis type reaction. And so let's do a simple synthesis type of reaction of, let's take H2 and let's react it with Cl2. And what we're going to produce is hydrochloric acid. So we have HCl, or hydrochloric acid. So we need to look at this problem and first identify, we need to identify the type of reaction that we're dealing with, which was a synthesis reaction. And when you have a synthesis reaction, you need to put your reactants together. Hydrogen was H plus, chlorine was Cl minus. Since they have both a charge of +1 for the hydrogen and a charge of -1 for the chlorine, that's how I get my HCl. Now we need to go back and balance it, so we need to update our atom count. Well, let's label the type of reaction first. This is going to be a synthesis type of reaction. 2 reactants yielding to a product. We do our atom count. We have 2 hydrogens on the left, 1 on the right, 2 chlorines on the left, 1 on the right. In order to balance this, let's go ahead and balance the hydrogen by multiplying them by 2, which changes my chlorine to a 2 as well. And the equation is balanced. Now, if the particular compounds that you're dealing with, or the elements that you're dealing with, do not have charges that cancel out, you're going to have to use your rules for writing formulas, chemical formulas. So let's do one that looks like that. So let's do calcium plus fluorine. Okay, we can identify this as a synthesis reaction. We have 2 elements joining together. It's going to form one product. And so we need to figure out what that product is going to be. So let's go ahead and think about some charges. Calcium is in the second column on our periodic table. Everything in the second column loses 2 valence electrons and becomes +2. Fluorine is in the seventh column on our periodic table. Everything in the 7th column gains 1 valence electron and becomes -1. So when we write our formula for our compound, we need to make a compound that's made up of calcium ion and fluorine ion. And since calcium is +2 and chlorine is -1, I need 2 fluorines to cancel out my calcium. So it's going to be CaF2. Now, just because it has a 2 on the right side in this formula does not mean that the 2 came from the original subscript of 2 on our fluorine in the initial part on our reactant side. This one, we're going to update our atom count. We're going to see something happens. 1 calcium, 2 fluorines, 2 fluorines. This one is balanced. This chemical equation is balanced. Okay. One more synthesis reaction for you, and then we'll move on to the other types of reactions. So let's take aluminum, and let's do the opposite of our first equation, and let's look at this. Aluminum, we're going to react it with chlorine. and see what happens here. So in this case, aluminum is +3. Chlorine is still -1. So just to prove to you that the subscripts don't carry from left to right, we need to figure out our products. And so we're going to take aluminum, and we're going to react it with chlorine, and we're going to end up with AlCl3. The subscript changed from left to right. You do not carry your subscripts through. You write all new subscripts. So now we can do our atom count. 1 aluminum, 2 chlorines, 1 aluminum, 3 chlorines. And then to balance this chemical equation, we need to put a 2 in the front there. That's going to change our aluminum to 2 to 6. A 3 here. That's going to change this to a 6. And a 2 here. And that's going to change that to a 2. Okay, so that's how to predict the product of a synthesis and a decomposition reaction. So now let's talk about how to predict the product of single replacement reactions. Single replacement reactions. Okay. Single replacement reactions can be a bit tricky. And the reason why they're tricky is because of something called the activity series. Okay, so the reactivity series is just describes how easily an atom loses an electron. And those that lose electrons more easily are more reactive than those that don't. So we need to refer to this list in order to determine whether or not single replacement reactions will occur. So let's look at one that does actually happen. And we're going to look at the one of my favorites, which is zinc plus hydrochloric acid. And I'm going to give you the states for this one. That's aqueous, which means dissolved in water. And then we have zinc, which is solid for this particular one. So now we need to figure out if this reaction will actually take place. And the way we do that is by determining which two will switch places if the reaction were to occur. So we know that zinc is positive, so it's going to want to switch places with the hydrogen, which is positive as well. So we need to see, is zinc more reactive than hydrogen? And we do that by locating zinc on the periodic table and hydrogen on the periodic table. So if we do that right now, we can tell that zinc is here on the periodic table. Zinc is right there on the periodic table, and hydrogen is right there. So zinc is more reactive than hydrogen. So because zinc is more reactive than hydrogen, this reaction will actually take place. So let's go ahead and look at zinc being more reactive than hydrogen and what happens to the reaction once it takes place. Zinc is going to switch places with hydrogen. We know that zinc's charge is 2+, and hydrogen's charge is, chlorine's charge is 1-. So we end up with zinc chloride, which is ZnCl2, and hydrogen gas, H2. Okay. Now for this particular problem, we need to go ahead and balance the chemical reaction. We know that we have 1 zinc on the left, 1 on the right, 1 hydrogen on the left, 2 on the right, 1 chlorine on the left, 2 on the right. So to balance this, I can put a 2 in the front here, and it changes this to a 2 and a 2. Okay. So let's just assume like this particular reaction did take place. Let's look at one that possibly will not take place. And the one that I use most often is reaction of an acid plus gold, for example. So we'll take gold, AU, which was solid, and we're going to react it with sulfuric acid, H2SO4. And let's see if this reaction takes place. And the reason why I talk about this reaction is because this is the actual way that if you go to a jewelry store or a pawn shop or any place that needs to test to see if gold is real, they drop some acid on it. And if it reacts, they know instantaneously that it's not gold or not pure gold. And the reason being is because we need to compare now gold to hydrogen. And because gold is not more reactive than hydrogen, no reaction takes place. And you can simply write NR or no reaction. Okay. Gold is less reactive than hydrogen. So no reaction takes place. Okay. The same thing can be said for copper, silver, gold, platinum. Those are all less reactive than hydrogen, so no reaction takes place, which is why you can also use vinegar, which is acetic acid, to clean pennies, because it gets rid of the dirt and debris and leaves nice shiny copper. Okay, the next type of reaction we're going to look at is called a double replacement reaction. Sometimes these are called precipitation reaction, because in order for this reaction to actually occur, you have to form a solid product, which is called a precipitate. So we're going to take two aqueous solutions and put them together. We're going to take an aqueous solution of sodium bromide, and we're going to react it with an aqueous solution of barium chloride. And for just right now, we're going to assume that all of these reactions take place. We're going to write out the products, and then after we write out the products, later on down the road, we'll determine which reactions will not take place, and we'll be able to identify the solid product. So in this case, we're going to go ahead and do the reaction as though it's going to take place. So this is the way that I do it. You can do it some other way. I tend to get these right, so you might want to follow along with me. Sodium is +1. Bromine is -1. So sodium is in the first column on your periodic table. Those things lose 1 electron, become +1. Bromine is in the 7th column. They gain 1 electron and become -1. Barium is 2+. It's in the 2nd column on your periodic table. And chlorine is 1-. It's in the 7th column on your periodic table. So in double replacement reactions, the positive ions switch places. Okay, so the positive ion from sodium bromide, which is sodium, is going to switch places with the positive ion in barium chloride, which is barium. You're going to get some new compounds. So what I like to do is I like to write my ions above my equation so that I can go ahead and write my formulas afterwards. So barium is going to switch places with sodium. You're going to get barium, which is +2, joining with bromine, which is -1. And I'm going to get sodium, which is +1, joining with chlorine, which is -1. And so now I can write my formulas because I know my charges. I end up with barium bromide, barium bromide, which is BaBr2. BaBr2 because you need 2 of the bromines to cancel out the 1 barium, and NaCl. Okay, I know that this is going to be aqueous. I believe this to be our solid precipitate. Eventually, we will learn how to predict the products of those reactions. We do need to do our atom count to make sure that it's balanced. We have 1 sodium on the left, 1 on the right. We have 1 bromine on the left, but 2 on the right. And we have 1 barium on the left and 1 on the right, and 2 chlorines on the left and 1 on the right. Excuse me. I said 2, it should be 1. In order to balance this equation out, we need to go ahead and let's go ahead and start with the chlorines. We have 2 chlorines on the left. We have 1 on the right. We can put a 2 here. It's going to change that. It's going to change this. Now I have 2 sodiums on the right. I can balance this out by putting a 2 over here, and that's going to change this and change the bromine, and now it's balanced. So there's an example of a double replacement reaction for you. Okay. All right, so now let's take a look at a word equation and predict the products of this equation and then balance the equation out. So we have sodium sulfate reacts with barium chloride. So let's write this out. We have sodium, and I'm going to write the ions out first. Sulfate, being SO4 2-, reacts with barium, which is 2+, and chlorine, or chloride, which is Cl-. So my first compound is going to be sodium sulfate, which is Na2SO4, because I need 2 of the sodiums to cancel out the sulfate, and barium chloride, which is BaCl2, because I need 2 chlorines to cancel out the barium. Now this is a double replacement reaction. I have 2 compounds joining together. These would probably be an aqueous solution. And now I need to figure out my new compounds. So to figure out my new compounds, I now am going to have barium joining up with sulfate. So we're going to have Ba, which is 2+, joining up with sulfate, which is SO4 2-. And we're going to also have sodium, which is +1, joining up with chlorine, which is -1. And so now I can write my formulas out. I end up with barium sulfate. They both have a 2 as their charge, barium being positive, sulfate being negative. So they actually cancel each other out. And sodium chloride, which is NaCl. Now we need to balance this. And the reason why I'm giving you this particular problem is because it does contain a polyatomic ion, which is sulfate. And so instead of breaking it up into sulfur and oxygen, because it appears on both sides of the equation, you need to go ahead and leave it together. So we're going to have sodium as one of our ions, sulfate as one of our ions, barium as an ion, and chlorine. And so we can do our atom count this way. We have 2 sodiums on the left, 1 on the right. I have 1 sulfate, 1 SO4 on the left, and 1 on the right. 1 barium on the left, 1 on the right, 2 chlorines on the left, and 2 on the right. Now, in order to balance, oops, there's only 1 chlorine. Call that a brain fart. So in order to balance this equation out, I can balance it out by putting a 2 in front on that side, and this is going to change that to a 2, and this to a 2, and it's actually balanced now. The next one that we're going to look at is ammonium hydroxide reacts with sulfuric acid. So we have ammonium hydroxide reacting with sulfuric acid. So let's talk about our compounds first. We have ammonium being NH4 plus, hydroxide being OH minus. The formula we get from that is NH4OH. And then sulfuric acid. There's no hydro prefix on this particular acid, so we know that it's going to be made out of hydrogen, which is +1, and sulfate, which is 2 minus. The lack of the hydro tells me that it comes from a polyatomic ion, and that polyatomic ion, because it ends with ic, is sulfate. So the formula for this is going to be H2SO4. Now, when we do these acid-base type problems, we know that ammonium hydroxide is a base because of the hydroxide. And I told you sulfuric acid, so we know it's an acid. We know that one of our products is always going to be water. And in this case, I don't want you to think of water as H2O. I want you to think of it as hydrogen hydroxide. And I'll show you why in just a moment. So the first thing we know is that this is a double replacement reaction. It's a special one called an acid-base reaction, and that the ammonium and the hydrogen are going to switch places. So let's go ahead and deal with the new compounds that are formed from a joining of NH4 ammonium, which is plus, and sulfate, which is 2 minus. And in this case, we'll notice that it's got to we need more than 1 ammonium. We need 2 ammoniums to cancel out. So we need 2 ammoniums to cancel out. And so in order to do that, we have to put it in parentheses. So we end up with NH4 2SO4. And then our other compound is going to be water. But remember, let's not think of water as H2O. When we do an acid-base reaction, think of it as HOH. Okay, for my class, if you write it as HOH, I'm okay with that. But just know that HOH is H2O. It's water. All right, now we can go ahead and balance this particular type of equation. And so we need to do our atom count, or our ion count in this case. And since we see polyatomic ions and they appear on both the reactant and product side, we can write them down as a single unit, and it makes your life a whole bunch easier when it comes to balancing. And these are the ions we're going to deal with. And so if we do our count, we see only one NH4 right here. So 1 NH4. On the right side, there's 2. Because of that 2, it's saying that there's 2 NH4s on the right side. On the left side, there's only 1 hydroxide. On the right side, if we look at the HOH part, there's only 1. On the left side, there's 2 hydrogens. We get that from here. On the right side, there's 1 hydrogen. We get that from here. On the left side, there's 2 sulfates. We see the 1 sulfate. And on the left side, there's 1 sulfate. And on the right side, there's 1 sulfate. So now we can do our balancing. And so to balance this equation out, I'm going to put a 2 in the front of my NH4OH. And that's going to change this to a 2. It's going to also change this to a 2. Now I need to get 2 hydrogens. And if I put 2 in front here for my hydrogen, I end up getting 2 hydrogens, but I also end up with 2 hydroxides. And so this equation would then be balanced.